Hey class, in today's lesson we're going to talk about solving exponential and logarithmic equations, which is found in section 3.4 part 1. Our objective is to solve exponential and logarithmic equations. So in example 1, we are asked to solve simple exponential and logarithmic equations. So the first thing that we really want to do is we just want to find a common base. So the common base of 2 and 32 is 2. So I would rewrite 32 as 2 to the 5th power. And since they now both share the same base, we ignore their bases and we focus on the answer, which is x equals 5. And I got that from their powers. Okay? If I have 1/3 to the x equals 9, again, we want to get them to have a common base. So even though 1/3 is a fraction, I know that 1/3 has an exponent, and let me write it vertically. So that's 1/3 to the x equals 9. This 3 is really to the first power, right? So if I change that to a power, 1/3 to the first power is the same thing as 3 to the negative first. Okay, and if I want to write 9 as a power with a base of 3, 9 is the same thing as 3 squared. All right, if I distribute this -1 in x, this becomes 3 to the negative x equal to 3 squared. Okay, now the bases are the same, so we will eliminate our bases, and we're left with -x equal to 2. And then finally, to get just a positive x, we're going to divide by -1. And so x equals -2. All right, and then our last problem, the natural log of x equals to 3. With this problem, what we want to do is we want to change it to log base e. So the natural log of x is log base e of x equal to -3. So if I write that in exponential form, remember log is base, so this is the base, this is the answer, this is the exponent. If I change it into exponential form, this is really e to the -3rd power equals x. Okay, and I can find what x is if I just type that into my calculator. So x is going to be about 0.05. All right, so that was the first 3 examples on example 1. So let's go ahead and move on to our try. So on try number 1, our first problem is the natural log of x minus the natural log of 3 equal to 0. All right, so the first thing that I'm going to do is deal with the fact that I have 2 natural logs, so a good strategy for us here is to add the natural log of 3 to the other side, and we'll see why in just a second. Okay, if I add the natural log of 3 to both sides, now I have the natural log of x equal to the natural log of 3. Now, based on one of our properties, because these natural logs are set equal to one another, then that means that their parts are equal as well, so x equals 3. All right, if we look at the second one, e to the x equals 7. So what we can do is we can apply the natural log on both sides. So for this problem, what I'm going to do is I'm going to apply the natural log on both sides of this equation. So what I have that was original is e to the x, and I have 7 still, okay? What's helpful is if you essentially applying the natural log on both sides helps us to eliminate the natural log of e, because the natural log of e we know is 1. So that kind of eliminates itself. So essentially we're left with x equal to the natural log of 7. And that we can find in a calculator, and we would get 1.95. All right, and then the last one, log of x equals -1. What will be beneficial for us is if we change this to exponential form. Understand that if you just see log x, then it's assumed that the base is 10. So let's write this in exponential form as 10 to the -1st power equals x. And if x equals 10 to the -1st power as a fraction, we know that that's 1/10, or as a decimal, we can say that that's 0.1. But either way, that one was pretty straight to the point. All right, let's take a look at example 2. All right, so on example 2, the main thing that we want to deal with when we're trying to solve these exponential equations is you want to get the exponent or the power by itself. If we can do that, then we can apply log and some other properties and get an answer. So on this first one, we have 3 times 2 to the x power equal to 42. My goal is to get 2 to the x by itself. So I'm going to divide by 3 on both sides. That's going to leave me with 2 to the x equal to 14. Now, with that, what I'm going to do is, since there is no common log of 2 and 14, I'm going to attempt to eliminate this base of 2 by multiplying both sides of my equation by log base 2. So if I multiply this side by log base 2 and also apply this as log base 2, okay, log base 2 of 2 we know is 1, so that kind of eliminates itself. And so what we're left with is x equal to log base 2 of 14. Now again, I can't do like a log is base situation, and so the only thing that I can do is do a change of base. So remember, if you do change of base, that is the log of the outer problem divided by the log of the inner. So that would be log of 14 divided by log of 2. And these bases are log base 10, which makes it nice for us. So if you throw that in your calculator, you're going to get about 3.8. All right, we're going to follow that same situation with a second problem. Again, our goal is to get the power by itself. So the first thing I'm going to do is add 4 to both sides. That's going to give me 2 times 3 to the 2t minus 5 power equal to 15. Then if I divide by 2, I'm going to get 3 to the 2t minus 5 power equal to 7.5. All right, now what I'm going to do is I'm going to do log base 3 on both sides of this equation. So this is because I'm trying to get rid of the power or the base. So this is log base 3 on this side, and this is log base 3 of 7.5. These will cancel to give me 2t minus 5 equal to log base 3 of 7.5. Again, the goal is to get t by itself, so if I add 5 to both sides, I'm going to get 2t equal to log base 3 of 7.5 plus 5. And then finally, I'm going to divide by 2 to everything. So essentially, I can put t equal, and essentially what I'm really trying to say is that I can put all of that into my calculator. And when I put that in my calculator, I'm going to get t as about 3.42. Alrighty, let's take a look at our next problem. All right, with our try, we have e to the x equals 72. Again, the whole point is that I don't want e as a base. The goal is to eliminate our bases, and we know the way to eliminate our bases is to multiply both sides of our equation by the inverse. So I'm going to multiply both sides of our equation by the natural log. So if I multiply by the natural log on both sides to our original, and again our original was e to the x on this one, and then 72 on this side, natural log of e will go away because it's 1, and I'm going to have x equal to the natural log of 72. If I just type that into my calculator, that's going to be about 4.28. All right, on the second one, if I have 4e to the 2x power equal to 5, and again, I just want e by itself. If I divide by 4 on both sides, I'm going to get e to the 2x equal to, as a decimal, that's 1.25. Again, I want to do the natural log on both sides. So it's going to be the natural log of e to the 2x and the natural log of 1.25. The natural log of e will just give me 2x left over. So I have 2x equal to the natural log of 1.25. Finally, I need to divide by 2 on both sides so I can just get a single x. And if I throw this entire thing into my calculator, what I will get for x is about 0.11. All right, let's look at our last example. All right, in example 3, we have a little bit more going on. This is actually kind of coming back down to quadratics. It's substitution in specifically. So if we solve e to the 2x minus 3e to the x plus 2 equals 0, what we're going to do is we're going to substitute x as e to the x. So for every e to the x that I see, I'm going to write it as an x. So let's first get everything in terms of e to the x. So e to the 2x is really e to the x squared, right? Minus 3e to the x, and then plus 2. All right? Now every e to the x I'm going to rewrite as an x. So this is now x squared minus 3x plus 2 equals 0. We know if we use AC, the two factors that we're going to get, because AC is going to equal 2, and the factors of 2 that give you -3 are -1 and -2, we're going to have x minus 1 and x minus 2 equal to 0. Okay, since that's as far as we can go with factoring those, we're going to substitute x as e to the x back into our problem. So this is e to the x minus 1 and e to the x minus 2 equal to 0. All right, since that's as far as we can go for those, we need to set each one of these equal to 0. So I'm going to switch colors again. So if I take this first one, e to the x minus 1, and set that equals 0, that's really e to the x equals 1. Essentially what we will do is we'll do the natural log on both sides. We know the natural log of e will cancel, so x will equal the natural log of 1. And we know that the natural log of 1 is 0, so that's our first answer. With the second one, if I take e to the x minus 2 and set that equal to 0, I would have to again add 2 to both sides. I would get e to the x equals 2. Again, I want to apply the natural log on both sides so that I can eliminate the base of e. And I would have x equal to the natural log of 2. And typing that into my calculator, I would get about 0.69 as my answer. And guys, that's it. If you have any questions, please be sure to come see me for tutoring.